In this video, we're going to look at gradient graphs for natural logarithms. Okay, so remember, natural logarithms means that the base is Euler's constant e, so 2.7. So if we are going to consider, first of all, we've got natural logarithm of x. So we can see already that at this point here, so we can take it right down here. So obviously there's going to be no gradient when x equals negative values or 0 because the function doesn't exist there. So we're going to just start off at this point. So the gradient you see is a very steep gradient. So you'll see that in a logarithm function, the gradient will always be positive throughout. And what's happening to the gradient, as you'll see when we run the animation, is this gradient is decreasing. And as we go from left to right, it's going to become less and less. Okay, so you see the gradient here is coming down and there's a very steep decrease. And then what's going to happen is we're going from left to right here is the gradient's going to become smaller and smaller as we go from left to right. Although it's going to look like it's going to go and this curve's going to become flat, it will never become flat, so you'll never have a point of zero gradient. You see a very slow change in the gradient now as we go in these values here. Okay, so when we're deriving a logarithm function, a natural logarithm, you will see that this function here is actually 1 over x. Okay, so this is a hyperbola. I mean, a hyperbola for 0 to infinity, not including 0, because that's the only place that the logarithm function exists. Considering another natural logarithm function, natural log of 2x, so what we've had here is we've had a dilation from the y-axis of factor of half, which has obviously made the graph a lot steeper. So you'll see this roughly the same point as we started before. You see the gradient is actually twice of what it used to be, right? Because you've had this dilation from the y-axis, which has made it a lot steeper. You've halved all the x values. So if we run this, then we'll see what we're expecting here. We're going to get the same shape. It's just that the gradient's going to be twice the value of what it was before. Okay, if we look at the first one, the gradient's actually just twice the value. So that's because this dilation from the y-axis has caused this function to all the x values to half, which means that it's a steeper. So therefore, the gradient's going to be a lot steeper. So for all of this, then we're going to have a steeper hyperbola. So when you differentiate the natural log of 2x, what we actually get is 2 over x, because it's twice the gradient. So the gradient function of natural log of x was 1 over x. The gradient of natural log of 2x is 2 over x because the gradient has been increased by 2. So a general rule for differentiating a natural logarithm is f of x equals natural log of f of x. The derivative then is f dash x over f of x.